leaders in
Hello and good evening to everyone. On behalf of the Office of Global Engagement, I am excited to welcome you to the 14th webinar from the IRIS webinar series. My name is Richu George Philip, and I am a part of the Office of Global Engagement. From the AI and Data Sciences Technology Cluster, the research initiative presenting today is Computational Mathematics and Data Science, led by Professor Nilesh Upadhyay. This research initiative aims at designing interpretable artificially intelligent mathematical models. Professor Nilesh is a faculty at the Department of Mathematics, IIT Madras. He is an experienced associate professor with a demonstrated history of working in the higher education industry. He is skilled in various aspects of mathematical modeling, R-stochastic modeling, and statistical modeling and data science. With Professor Nilesh on the panel is Professor D.S. Sundar, Dad Research Ambassador, Department of Mathematics, IIT Madras. He is an experienced professor with demonstrated history in the higher academic education industry. He is skilled in various aspects of mathematical modeling, simulations, and computational mathematics. Joining us as the moderator today is Professor Agnieszka Wyomanska, professor and faculty at the Department of Pure and Applied Mathematics at Wrocław University of Science and Technology. She is a member of the Hugo Steinhaus Center for Stochastic Processes. In 2015, she received DSc degree in Mining and Geology from Faculty of Geoengineering, Mining and Geology at the Wrocław University of Science and Technology. Her area of interest relates to time series analysis, stochastic modeling, and statistical analysis of real data, especially technical data related to mining industry, indoor air quality, and financial time series. She is an author of more than 100 research papers. She cooperates with industrial companies, especially from the mining industry. Thank you for joining us, Professor Agnieszka, Professor Nilesh, and Dr. Sundar. A note to the participants, please use the Q&A to enter your questions and upvote questions that interest you so that the moderator can prioritize them later. Over to you, Professor Nilesh.
Thank you, Richu. So I will share my screen. Yeah. Is my screen visible?
Yes.
Okay, thank you. So today's talk is focusing on Center of Excellence for Computational Mathematics and Data Science. So with me, as Richu introduced, I am the principal investigator. With me is Professor Sundar, and along with us, our today's moderator, who is Professor Agnieszka Wyomanska. And let us first start the webinar by why the need for such a center in computational mathematics and data science. So why this COE in particular? Most of you are familiar with a boom in data science. In fact, most of you are attending this webinar because of this boom in data science. And data science is synonymously used another terminology called machine learning. So machine learning and data science together is the buzzword of these days. But these two techniques, this data science and machine learning, they lie on the basic foundations of mathematics and statistics. Now, what happens when it comes to the usage of these data science techniques? Most of the practitioners sideline the principles behind these principles that are used behind machine learning algorithms of mathematics and statistics. And they use these techniques as a plug and play criteria. What do I mean by plug and play criteria? Let me elaborate. So when you use a machine learning algorithm, that machine learning algorithm is based on some assumptions. When you are using that machine learning algorithm, you need to respect those assumptions. And when you are using it as a plug and play criteria, you are disrespecting those assumptions. So on a given data set, the machine learning algorithm may perform better, but you don't know what is happening inside the machine learning algorithm. We will call that as black box model. So when you don't have any idea about machine learning model and you are using the machine learning technique, then what happens is the outcomes that you get, if you get your favorable outcomes, you are fine. If you don't get your favorable outcomes, then you say this machine learning technique is not working. Whereas the fact is the machine learning technique was not interpretable. And most interdisciplinary researchers make this mistake of using machine learning techniques as plug and play techniques. So why we are saying this? Because this, in our opinion, is disastrous to development of any scientific endeavor. And this can be seen, this kind of opinion can be seen in several articles that are published on machine learning. And in particular, I have chosen one article which is published in Nature Machine Intelligence recently by Cynthia Rudin, which says how machine learning can damage, how uninterpretable use of machine learning can damage even these machine learning black box models were implemented in healthcare computer vision, as can be seen from the abstract. And she is recommending us to replace those machine learning models with more interpretable models. So this is where we stand. Now, as our center of excellence, we want to make these black box techniques more interpretable along with our skills. So that brings us to the mission of our center of excellence. What is the mission? First thing is make these black box models more interpretable. So what is a black box model? Let me elaborate for 30 seconds. You have been given some input, you have been given some output. Now you are told to amend the input in such a way that the output produced is this. You don't bother about what is happening inside. You simply produce an output. Though you may use some mathematical tools, but those mathematical tools are used based on certain assumptions. You don't really worry about those assumptions, and you don't have any performance metric to measure those assumptions. Therefore, you will get the output when you use the data set that is available to you and you fit this black box model, it will give you awesome results. But when you actually take a new data set and try to implement this black box technique and get output, you may not get, or you may get suboptimal results. That is what the black box technique is. Now, what you will do if you are presented with a black box technique, you can leverage our skills at this center in mathematical and statistical modeling, get true sense of the data. You can have many exploratory statistics designed, and you can get the true sense of a data. Then use the first principle, domain-specific knowledge, first principle modeling, and get the basic facts out of the problem at hand. Once you have the understanding, then combine all these three and force yourself to produce an interpretable, artificially intelligent mathematical model. So when you do this, you can see on the left, on my left, there is a hierarchy of models that is being displayed. You can see here. So this is the space of completely unknown data sets. And from that, you are using a black box approach. You are actually designing some internal structure which you are not aware. You are simply tuning the parameters and getting the data to fit. That is a data-driven model. Whereas this first principle modeling that we are saying is actually a white box modeling or a transparent box approach, where you know the structure, you know the parameters, you know how they behave. So you want to make use of these first principles along with our statistical modeling and mathematical modeling to come to this gray box kind of modeling, gray box approach, which may use some part of black box approach, but the results that you will get are certainly interpretable. This is where our focus stands, and we are dedicated to make our models interpretable. Now, this is about our mission. Now let us have the list of people who will help us in doing so. So these are our list of collaborators. One among them is our moderator today, Agnieszka. Okay, so this is the list of our collaborators. Now let us have a quick glance through our projects. So these are only key projects that I am displaying. We have already undertaken around 8 projects. So first project is Pedestrian Crowd Dynamics Model. This is the proof of our concept, how we will design the interpretable artificial intelligence model, which will be explained in detail by my co-PI, Professor Sundar. So as you can see some figures, which are actually displaying the density plot of pedestrian obstacle interaction. Then next is the simulation of particles through the fluid. So we have already simulated. Using machine learning techniques, we will improvise this simulation. Second, this is a 2D simulation. This is a 3D simulation. Then we have also handled various problems in multivariate time series modeling for heavy-tailed noises, which was our major part of our research. Okay, and then finally, I will present to you something called automated synthesis. This is our ambitious goal. We want to come up with this particular tool. Okay, so let us go ahead and try to see multivariate time series analysis for heavy-tailed noise. So when you say heavy-tailed noise, where do you encounter this? These kind of cirri are encountered in modeling the financial data. So I will show you. So the first problem in this heavy-tailed noises is they are difficult to have the estimate. Their parameters are difficult to estimate, in the sense, if the time series comes from a heavy-tailed noise. So in particular, I have plotted 2 time series which are very specific to Indian context. This is the traded data of TCS and NTPC. And you can see this return time series are stably distributed. And to estimate the parameters of the stably distributed time series, return series of this, is very difficult problem. So we have used a simple machine learning technique to estimate these parameters, which is comparable with linear regression model. And we were able to come up in short span of time good estimates for these stable distributions. Another thing, while handling the stable distributions, the variance of these stable distributions is not finite. So you need to come up with some measures of dependence, which will measure the dependence between the 2 cirri. That is covariation, which is designed by our moderator along with my co-PI. And they have come up with covariation-based Yule-Walker method for multivariate time series with stable noise. This can pretty well explain the behavior of the stock price. In similar spirit, we have also worked with vector autoregressive time series model. We have gone further. We have used ARMA, autoregressive moving average, with variable covariations. So ARMA GACH models we have introduced and we have estimated them. And we have implemented them successfully. And all this is published work in various top-class journals. Let us come to our next problem, which is automated synthesis. Automated synthesis is one of our ambitious projects where we want managers to use machine learning technique and make better policy decisions. So let me explain this in 2 minutes. So our goal is to design a general purpose decision-making tool, which will enable the use of data and the parameters of the interest, which will be fed by the managers, and to give them various models with performance metrics. These performance metrics will make the black box models that we are using interpretable. So as you can see, here is the graph that I have shown. So this is the design complexity, which is on a relative scale, varies from low to high. And this is the effect required for designing in each iteration. Now, when you are handling a simple problems, then the effort required is very less. Where you are appointing a manual labor, so more or less our tools will not help. But as you go higher and higher in design complexity, like graphics, music, apparels, the efforts are more. In a similar spirit, if you want to design architecture and urban systems, the effort is still more. If you want to define some mathematical models, AI, machine learning pipelines, or investment strategies in finance, the effort required is still more, and so on and so forth. So when you use this tool and when we will present our models, our estimates are, we will have the effort required in each design will be less and less as the design gets complex and complex. So this is our ambitious goal, and we are planning to achieve this by 6 months or 1 year term. Now over to Professor Sundar for giving the proof of concept with pedestrian crowd dynamics model. So Professor Sundar, can you take over?
Thanks.
I will stop sharing, then you can.
You please stop sharing. Good evening, all. Thanks for coming. Thanks for your presence for this webinar on our COE initiative. So what I'm going to quickly go through is one of our recent work on pedestrian crowd dynamics modeling. And here you will clearly understand what we mean by the transparent and white box model. You cannot have the same problem. You can have a black box model, like a kind of observation. You collect the data and try to do the analysis like a black box model. But as Dr. Nilesh pointed out, it's most of the black box model it works for the maybe true for the one which you have already tried. But on the unseen data, then it's very important that you need to go for first you need to analyze through the white box model. So here is the one. I'll just go through, quickly go through the my slide. So you are able to see the slide. Please kindly.
Yes.
So I'll quickly go through the slide. So basically on modeling and simulation of pedestrian interaction with obstacle and application to pedestrian vehicle traffic interaction, and also this is also talks about the disease contagion in pedestrian crowd. So this is a joint work with my student Parvina Shamim. She is at Kaiserslautern now with our collaborators, Dr. Axel Klar and Professor Axel Klar and Dr. Sudarshan Tiwari. So basically the motivation is static obstacle avoidance. It helps you to, this particular model definitely helps you to static obstacle avoidance. What are the existing models? Usage of shared spaces. Then motion planning, robots, autonomous vehicles, and crowd control. Okay. Now, the moment you go to this, I quickly go to because I just to flash, give you some, a quick glimpse on how the model looks like, because it's very important mathematically how we capture. Okay. So there are models with the pedestrian model. How are you going to model the pedestrian, the crowd? The microscopic model, meaning you are labeling the individual pedestrian and trying to observe as we can put yourself as a person traveling, going inside the crowd, and as if you are and that way you try to model. So it's a micro model. So we need to understand that because it's pedestrians are moving, so the position of the pedestrian, d by dt of xi, and d by dt of this is basically the talks about the motion. Then it is basically surrounded by the things of what are the forces acting on this. So the forces, what is happening when we walk, when a pedestrian is walking, what are all the forces influencing his movement? Okay, his motion. So this is more important. It's called the social and behavioral forces, which has to be taken into your model. So in this particular white box model, the main modeling concept is how to model these forces. How to model, there are different types of social, the forces has to be modeled. And this is the one, the G is the one which talks about what is the shortest, because the pedestrian, when he is entering into a particular street, then he wanted to go to a particular place, so or particular shop or particular location, then how fast he is going to reach that particular location. So this is the shortest distance, how they are depending upon the density around him. So this is basically a micro model. You are fundamentally labeling the pedestrian, each pedestrian according to this given geometry, then trying to model the forces. So there are the social and behavioral forces are very, very important. And how are you going to identify the social and behavioral forces when to avoid the pedestrian collision, how the pedestrian is interacting with the boundaries, how the pedestrian is interacting with the teams, when they go like a group, then or the family, then how they interacting with the team. So all the forces has to be precisely captured into, that means has been captured in this particular model. Then another level of model is this is a micro model, this hydrodynamics model, which I would call it as a macro model. So you don't label the individual pedestrians, but you talk about in a crowded street and at a point, what is the density at a point? Okay, density of pedestrians at a point. So that is basically the row. Then this is basically the average density at a point and at a particular position. Similarly, what is that particular ensemble is moving? What is the velocity and what is the equation of motion? Again, here, according to this hydrodynamic, the macro model, we have to model the forces corresponding to. So corresponding to this, what are all the possible forces which is acting this particular movement of this? It's not individual pedestrians. It is basically at a point, what is the average density which we need to calculate, then how this particular thing is moving with what is the average velocity. The Eikenal equation is a very important thing because it is helping you in this particular model to get into the shortest distance to reach your the points. So there's a velocity density relation which has to be given in this model. So one such model, general model for a velocity density relation is this. I'm just giving you a kind of a bird's eye view on what are all the possible models which we have gone through and we have which we have also developed. Now the previous one is for the pedestrians. Micro model, individual pedestrians and pedestrians at a point. You are looking at it as a density. Then try to capture the forces and try to capture what is the shortest distance. So micro and macro. Now, the moment you have an obstacle, the moving obstacles, then we need to talk about how the obstacles are moving. So there is a passive obstacle. So what is the d by dt of basically the x0 is the O is meaning the obstacle and velocity of basically the total velocity, and how are you going to model the total velocity? This is for the passive obstacle. But when you have a dynamic obstacle, so what is the basically how the obstacles is moving? For example, the obstacle may be a vehicle. A vehicle is moving inside the crowd, or some vehicles are a cycle or a two-wheeler or a four-wheeler, which is moving inside the crowd and maneuvering through the crowd and going across. So this obstacle dynamics has to be modeled. And the obstacle, then d by dt of the position of the obstacle, then what are all the acting forces? Then how the obstacle, what is the movement of the obstacle and what is that particular obstacle shortest distance? Again, this is the Eikenal equation for the obstacle. So the passive obstacle model, dynamic obstacle model, along with your pedestrian thing, it has to be integrated. So now the moment, as you know that you have the first top one talks about the pedestrian, whether the second set of equations talks about the obstacle. Okay. Now all these equations along with appropriate initial and boundary conditions has to be solved numerically. So one of the method which we have using here is a mesh-free particle method, which is basically based on the least square approximation, which is a Lagrangian formulation, because we go along with we as a point moving along with the crowd and try to observe how the flow is. Then we need to have a time discretization and as well as the space discretization. Space discretization is done by mesh-free particle method. The time discretization is Euler explicit, meaning what I mean to say that not only the model, and we need to check the mathematical legality of these equations, mathematical legality, then only along with the initial and boundary data, then what is the correct numerical method which will be able to, assuming that the model is right, and which numerical method able to reflect your mathematical model. So this numerical model has to be very tight and has to be checked for a complete mathematical legality. So what type of grids we are going to use here when you talk about numerically? It's a mesh-free cloud particles. Then we need to have Eikenal structure and unstructured mesh. Obstacle as a immersed boundary. Activation and deactivation of grids, because and interpolation of density. Okay, so all these things has to be taken care when you do the gridding. Okay? So numerical part is also very challenging, very interesting, very challenging. Now, when you have vehicles on road, so there's a normal obstacle. Now I take when you talk about a vehicles on road, then the vehicles has to be modeled. So the desired acceleration of the vehicle has to be put in. The obstacle, what I'm telling is, obstacles or some kind of taking those equations are valid when it is for the not the vehicle, but which are the obstacles which are moving. But here it's for a particular the vehicular motion. Then we need to understand XIV talks about the vehicles. So now we need to model the motion of the vehicles and what are all the possible interaction forces which we with the leading vehicles. So that has to be modeled. So this is when you have passive obstacle, moving obstacle, when you have a vehicle, what is a model? All these things has to be properly and captured and brought it under your along with your pedestrian. So let me show some of the simulations, 2D simulations, which will. This is a traffic pedestrian interaction at uncontrolled crossing. There are vehicles which are moving, obstacles which are moving, or you can take it as a vehicle which are moving. Now the pedestrians are the green one, which are starting from here. Now you see that how they are. It's uncontrolled, meaning there is no zebra crossing. So you see that how the pedestrian, they try to find out this place and try to cross from one place to another. Okay. Now I go to the next slide, next video. This is on the zebra crossing. How the pedestrians are. Yeah, the vehicles which are coming and seeing the people crossing the zebra crossing, they just wait. Okay. So now we go to the next, as I told you, how this model we have extended this model for your for the infectious disease spreading, and for that we try to have this particular model, and we have converted that one into. So now in that case, it's called a kinetic evolution equation. So now that K is SEI, susceptible in a crowd, and this is E is the exposed one, and I is the infected one. So how that model is modified into if you are in a crowd and some of the some of the people who are walking in that crowd, they are susceptible. Some of them are exposed to this one. Some of them are infected. So how this infection is going to spread? So this is a important thing, and it's just a direct extension of the model. What we did, the pedestrian crowd dynamics with the obstacle, with the vehicles, and that model has been further extended to the disease spread. So this is the TK from SIES type disease spread, how it has been modeled. Okay. So this is our model. Now this is the, we look at it as a multi-group hydrodynamic model. Equation for S, equation for this, rho is the density. So corresponding equation for S, equation for E, equation for I. And this is basically the equation talks about combining the equation of motion. Okay. Then hydrodynamic model using volume fraction. So the model which you can use using the using the volume fraction. The model is now modified. There is another model which uses the volume fraction. Okay. Now you see that with the static obstacle, whatever these are all the persons who are bidding. I'll show you the video so that you'll understand. So a crowd is going with the blue one is basically the red one is blue one is exposed, red one is infected. So how when they are moving, how they are basically how the disease spreads when when the crowd is moving. So this is with the moving obstacle. You see that you follow the red and blue. then how much blue, whenever they go near to this one, there is an increase in the exposed, the red one is exposed one, blue one is infected. So how that red one is infected from the blue one, and the blue one is again infected to the another blue. So while moving in the crowd within certain time duration, how many people got infected? It has to be, all these things has been, this is the visualization through our model, but all these things have been measured and computed as per the real situation. Okay, so this is the observations which we made, and this is in our court, which we are right now. Some of this work has been accepted, will be published soon. So these are all some of the observations from this. It's only an overview. Okay, I just wanted to tell you that what we mean by the white box, the transparent model, which is important in order to have a so what we are trying to basically what we are trying to put here is our aim is take this is the data which we have generated the geometry. Now taking this situation to a real crowd on a particular street. For example, in Chennai, go to the crowded street, and now look at the peak hours moving the crowd movements along with the obstacles which are crossing. Now take that particular video for a couple of minutes. Now take that one as an input, put it into your model. Now in our model, whether the model what we have the model which we capture this particular crowd dynamics. This is very important in order to test. We can measure it according to the reality. We can measure it through our model, like a density at a point, average speed at a point, all the essential quantities, physical quantities can be computed through our model. Allow the real video to go for a couple of minutes. Allow your simulation, which you have taken it from your input is from the real model, and try to allow it through your mathematical simulation. Then see how close these are by visually as well as by these measures. This is very important because the moment you go into the mathematical modeling and try to, what Dr. Nilesh was, what we are trying to tell is this white box approach is essential component in order to make sure that, in order to precisely capture the crowd dynamics, which is very, very important in order to, you want to make the process, the entire thing, a control or any process on the automized or automated control. So what I'm saying is, now take the data. Or the moment if this mathematical model is running, it generates a data. So that data can be it's fundamentally the data on a known situations. Now through this data, you try to have a machine learning algorithm to understand, to learn. Then from that machine learning algorithm, you try to you will try to make it how this particular machine learning algorithm, which has been developed through this white box model, and how this can be applied on a unseen data. And this is our main goal. So it's of course I took a little bit, but I wanted to just emphasize on what is our kind of overview on what I mean by the white box model and how we can get into the machine learning. This is our next step, which we are planning. Thank you so much for that.
So can you stop sharing the screen?
Yeah, I do. Yeah.
Okay. So now, after automated synthesis, now let us see what are the deliverables of this center. So obviously, as you can see from his presentation, that we will deliver high quality research output. Of course, those who work with us and who do courses with us, we will have a human resource development. If industries approach us, we will have better interpretable solutions to our industry-based problems. And of course, with this initiative, we are aiming to have increased awareness about modeling techniques among the practitioners via our workshops and conferences. So these are our deliverables, and that will definitely impact the society. And then finally, what are the opportunities you have? Any industry who is looking for interpretable solutions to their research projects is welcome. We have already been working with industries in the areas of foundry, where sand and metal analytics is taken, jewelry design, of course, finance, and in the sector of agriculture. Another thing, for those students who are interested in studying something about machine learning and interpretable models, we have programs which we will enroll soon, certificate courses, then IITM, some joint degrees or online degrees, then research internships with us, postdoctoral fellowships, project associateships, regular research fellows, those who seem to be expert, who feel that they are expert, and they are not Indians. Then we have our Young International Faculty Scheme, which can be seen from the Global Engagement Office. If you have any queries, please contact us on the email ID that is given to you. This is our email ID. You can call me on this number, and you can reach us in the Department of Mathematics, IIT Madras. So finally, thank you for your time and patience to listen to us. Thank you. Over to you, Professor Agnieszka.
Okay, good afternoon. So before we start the questions and answers, I want to highlight few important points that were given here. However, I think they are worthy to highlight once again. So the goal of the proposed center is to transform IIT Madras into the world leader in the scientific discovery through the new pillars. Any scientific progress can be made with a strong foothold in mathematics and statistics. On the other hand, without the interdisciplinary cooperation between research and industry, science has no chance to move forward. The main goal of the center is to develop a new mathematical and statistical methods in order to apply them in real-world phenomena. This is the most important message of this center. From the international collaboration point of view, this is a chance for IIT Madras to inclusion in ongoing research carried out abroad. On the other hand, there is also a chance for the collaborators, so the researchers like me, who cooperate with the people from IIT Madras. We will have a chance to learn and develop new techniques together with researchers from IIT Madras. So IIT Madras is now one of the most powerful research centers where new methods appear. This is a center for new ideas coming from the real problems. Thanks to strong cooperation with the industry, IIT Madras develops methods that have a chance to be implemented in real environment. Not all centers in the world have such a chance. So from my point of view, I am proud that I have an opportunity to be involved in the new idea and hope that the cooperation initiated a few years ago will be continued also in this initiative. Okay, so now I think this is a time for questions for Professor Sundar and Dr. Nilesh. I see here many questions. Some of them are very general. Some of them are very, let's say, detailed. So let's just start with the general questions. So the first question is, how would you like to involve the industry in the research? So how it is possible and how you will organize this cooperation with the industry?
Okay, so I have given my contact details. So any research-based industry-sponsored project is welcome. If they want to, if they have the task force at their in-house task force, and they just want our guidance in their research project, then we can have an industry-based research consultation. Another way to engage with the industry is we have our popular programs like MTech and other online degree programs where students are involved, and we can assign our students to work with on the research projects which are given by industry. So they will be in direct touch with our students, and we will just monitor them. So these are the three ways in which we can collaborate with the industry. So Professor Sundar, if you want to add something, you can add.
Thanks, Dr. Neelesh. So what I wanted to say, the one which I have presented, which has been tested on a toy, on a synthetic situation. Now, as I told you, this will be going to be implemented, checked on a real crowd according to Indian roads, Indian locations. Then this will be tested through our model. Then we are planning to convert this one into a machine learning algorithm. The data is collected from this model, and then we go to the machine learning model in order to use those machine learning model on the unseen situations, unseen data. So in turn, this will help us to. So this is the place where the industry is coming in. Now, when we want to automate a kind of automated system, automated process on this type of evacuation planning, crowd controlling the stampedes, automated process or automated system, this way we will planning to interact with the related industries. So this is one thing, but it should be research based, as Dr. Neelesh pointed out. Research based consultation, research based projects. These are our main aim in order to interact with it might be a public sector or it might be a private sector.
Okay, thank you very much. So another question which is very close to the previous one, is it planned to involve also researchers from other disciplines? If yes, so please tell how to do this.
Yeah, I think we have already been involving researchers. Right now, I think Professor Sundar is working on a project with civil engineering for a simulation of the particles of the fluid. And any problem in any domain which is research based and has the data is welcome. We are ready to handle it.
There are two projects which are already with the other engineering groups. One is with the environmental engineering. Another is with civil engineering.
Okay, thank you very much. So now we have a very important question from the audience. What sector to be covered for the data science?
Can you repeat what is the question?
What sector to be covered for the data science? I mean, probably in the center that you proposed. What sectors? What kind of sectors you want to involve in the
any sector? We are open to have data from any sector. Only thing is they should have a research problem associated with the data. We are ready to develop a mathematical model.
Okay. All right. So now I see.
Main idea is it should not look like we have some softwares and they want to use their data into that and trying to put it into your software and give the results. It's not that the model. We need to develop the model from the scratch and develop the entire system.
Okay.
So and it's not restricted to, as Dr. Neelesh pointed out in one of his slides, already we are in touch with the industries where they are already doing such a model for agriculture industry. And we have not mentioned the name of the industry. And also some of the so already textile industry. So what basically what they are doing is they are already they are not restricted to a particular industry. That's what.
Okay, thank you very much. This is very important. And now I see a few questions related to the black box, like Dr. Neelesh mentioned. What do you mean black box? Could you please give some examples about black box, gray box, and white box?
Yeah, that's a good question. Black box model, see in any modeling, we have two important white box modeling, which you travel along with the problem. Like in this crowd dynamics model, if you look at our micro model or macro model or the obstacle movement, then you have a vehicle's movement. We travel along with that, travel along with the problem and what is happening when a particular pedestrian is walking along the road or in a shopping zone, how he is looking at the surroundings. So then you try to model, capture the forces. So this is basically the white box model. The black box model is something like you don't need to do, you can put some kind of, you have a camera here and there, you have you can capture those camera, you collect the data directly. So now from the data, you collect the data, you tell that during this time to this time, at every 1 minute, at every second, the density at a point is this much. You collect the data directly from the scene. Now, what you try to do is how that now once you collect the data on different timings, on different days, on different this one. Now you have the data. Now you try to analyze with this data. Question is, the model is developed from the data, but we don't know whether the model is exclusively or a dedicated model for this data. Right now, you can see that a lot of statistical, a lot of models which you can put it, which you can work on your. So you have a genetic algorithm, you have a neural network, you have so many. So what is this one is, you can use the data same model with certain modifications for for medical data. Then if your data is finance data, still you can use similar models. If you have another data which is from the stock market, that can be used. So the moment you have the data, the black box model, the meaning of black box model is you collect the data from the observation. Go to the experiment, collect the data from the observation, you try to model. This we call it as a the white box model is the one where we travel along the problem.
Okay, thank you very much. So I have also one additional general question. How is data science related to the artificial intelligence? How we combine?
Yes. Okay, so shall I answer this?
Yes.
Yeah. Okay. So so now there are mixed terminologies that are used, like what is data science and what is artificial intelligence. When you look at artificial intelligence, it is about how you define it. When you define artificial intelligence as mimicking the movements of human brain, then it becomes somewhat tricky. And if you define, so basically, if artificial intelligence is defined as the model that will mimic the movements of human brain, that means you will talk in terms of robots, you will talk in terms of some surgical arm, or something of that sort. When you look at data science is typically related to the mathematical models. So now this terminology of artificial intelligence and data science in most of the literature is used interchangeably. If you classify that artificial intelligence to be a robot-based intelligence, then you should have mathematical models for the understanding of the robots that are intelligent. So that is how data science and artificial intelligence are related. I hope I have answered partially.
Okay, thank you very much. Professor Sundar, do you want to add something to this? Okay, so maybe another question which is related to this. I see here a few questions. So people are asking, I am not good in mathematics. I am not familiar with mathematics. Can I use artificial intelligence methods? How can I use, or give me some guidance? What to start?
No. Yes, you're right. But as a user, as an end user, whenever such things are developed as an end user, you don't need you just use how to you know how to use it. So we are talking in terms of how to develop such a algorithm, how to develop such a model, how to get into those computation and making it to the level of automated system. Then in that case, when I touch any machine learning algorithm, you must have a strong background in your. You should have a strong mathematical tool. For example, linear algebra, probability and distributions, optimization, multivariate optimization. All these things are a very strong tool which is required. In turn, when you go to a white box model along with the then it becomes a differential equations. So according to the problem domain, not everyone is expert in all types of problems. If a particular person is interested in a particular class of problem, then what is the mathematics behind? If you are a developer, if you are a person brain behind this particular model, brain behind this particular entire system, then the mathematics is a must. As an end user, as we are using so many things as an end user, it's like we don't know what is happening inside, but still we use it. We believe that whatever it gives is right. Then it is not an issue. But if you are a person to develop, definitely mathematics is a must.
Okay, so as an end user, if they want to use these models, then we have performance metric associated with each model. So if they know how these performance metrics perform, that is good enough to use the model. So there is no need of them to have expertise in mathematics.
That is also possible. Yeah. You can use it, but there will be a performance according to their industry need. We will be able to, through our model, we will be able to give that numbers.
And because our models will be interpretable, we will be able to give exactly what this performance metric tells about the parameters of the model.
Exactly.
Yeah.
Okay. So now I have a few detailed questions, mostly related to Professor Sundar and his talk. So what is the difference between dynamics, obstacles, and vehicles?
No, I'm not getting. What is the question?
What is the difference between dynamic obstacles and vehicles?
Yeah. So the moment I say the vehicles, if you look at the model carefully, when the vehicles will have the acceleration of the vehicle depends upon when the vehicle is on road, what type of road it is, what type of crowd it is moving through. So the vehicles will have the acceleration, the forces surrounded by the vehicles, and how the driver is reacting as per the crowd movement, or another vehicle in front of this. All the examples, whatever I have shown, one vehicle to another vehicle, and in between the crowds are coming in. So the vehicles model is different. When I say some obstacle, or you just imagine that non-vehicle, non-accelerated this one, then depending upon the type of obstacle, we need to, so vehicles will have a different forces. Depending upon the another kind of obstacle, we will have the forces surroundings are different. That's what I.
Okay.
Or you just take any, for example, obstacle means suppose you assume that on a crowd there is a big rock or big ball which is moving, or in a crowd a big rock is rolling. Okay, and or in your mall, when you go to a big mall and all, the people will be playing, and there's automatically or some obstacles will be just moving here, and you somehow avoid the obstacle or just stand and watch the obstacle what is going. So this is not the vehicle dynamics is different. This obstacle things are different. Just imagine there is a rock, a spherical rock which is rolling on the street.
Thank you for the explanation. So
or even the obstacle might be how the pedestrians are behaving in front of in flood. If there is a heavy rain and the flood is coming, then so that model is different.
Thank you. Okay, I have one general question. I think this is general. How do I select a mathematical model or equation for a completely new machine learning problem?
No.
That's a really general question. Cannot be answered precisely. It's vague.
Yeah.
See, that's what I told you. Machine learning, whenever we say that, so for what our purpose is, you generate the data from the white box model, then collect this as a data and use this one for your machine learning algorithm. And in the strategic, So what we are trying to tell you is another way of doing things is you take the observation, directly take the observation and collect the data according to the problem. Then use the, so now what we are trying to emphasize is this one, what we are trying to tell is mathematically interpretable than the other. That's what we want.
Okay, and that can be partly answered by our other project, that automated synthesis project. If you have a data and if you are planning to have a model, you input some parameters and we will give you the machine learning models that are suitable related to your problem.
And one thing is clear, there is no generic machine learning model, generic machine learning technique. There is no generic machine learning algorithm. It has to be addressed from problem to problem. Data, it varies. That's what. The problem with the black box model is this one. Some of these generic models, which we, in quotes, we say that we try to use it for different data, the same. So it has to sense what type of problem we are using. Is it a dedicated model? So there is no general machine learning algorithm or technique in solving all types of problems. It has to be developed according to the problem domain, according to this model. Then based on that, we have to.
Yeah, thank you. So here I see at least 2 questions related to sharing once again the contact details, because maybe it was too fast for audience.
Yeah, but I think our global engagement office will take care of that, because this will be in our website and all the details will be placed.
Okay, so there is also another question. Probably one student is asking, is it possible to involve in your project students? So I mean bachelor's or master's students. So
yeah,
how can they apply?
Yes. Bachelor and master's, yes, definitely. But provided they should not take it as a, what is that? We are teaching them spoon feeding. It's not like that. If they have a good knowledge, good mathematical and computational knowledge, where they are able to convert that thing into a coding. So they have to go up to the coding level. Yes, welcome. Yeah, any good students, we have always a place.
Okay. Okay, so here I see also some questions from PhD students. Of course, the same story, we can involve the PhD students in your project.
Yeah.
Research, yes, of course. Okay.
So all the problems, whatever we are right now working, is along with our PhD students. So this is that's what from the beginning we are telling that it's a research-based.
Okay.
We have to develop the model, understand the legality of the mathematical, all the legality it has to go through. Numerical thing it has to go through. Then numerical stability, everything has to be understood. Then developing the algorithm, then the coding, then collecting the data, how it works on the real situation, then collecting the data, put it in, develop a machine learning tool. So there are various stages, various challenges.
Okay, so I see here some questions. So people are asking, do you know some good books in machine learning, neural networks, or do you offer some, I don't know, courses, online courses for this topic? What do you think about that?
Yeah, there are a lot of good books. Right now, we cannot mention it here, but there are quite a lot of good books on machine learning. But in order to understand this one, it's better always to involve in certain projects and go from the. But in general, machine learning, there are a lot of good books, good videos are available right now in the market. So very interesting books, but I cannot tell right now.
But we cannot suggest any one because.
Yes, exactly. And the new articles appear every month, of course, depending on the problems, on the data, and on the questions that there are. Yeah. Okay, so I see most of the questions were answered here. So some of them were general, as I mentioned, some of them were very detailed. So from my side, I see that you answer all of them. So from my side, thank you very much.
To the extent possible, we are still at the beginning, and we are in fact trying to achieve our goal, whatever we have started with. That is the whatever we have planned.
Okay, congratulations for the ideas, for the initiative, and good luck. Thank you very much.
Thank you.
So thank you to all the participants who have participated as well. They have spared their valuable time. And Agnieszka, obviously, thank you very much.
Thanks to.
We are very much grateful to you for sparing your valuable time.
It was the privilege.
Thanks, Professor Agnieszka.
Thank you very much.
And Global Engagement Office for arranging such a wonderful webinar.
Now over to Ms.
Richu.
Thank you, Professor Agnieszka. Thank you, Professor Nilesh and Professor Sundar. I'm sure it was a really, by the number of questions, I can tell that the audience was fully engaged, and I'm sure they would have enjoyed it if it went on longer, but we do have a time frame to stick to. So thanks a lot for being here and spending all the time with us and explaining to us what your research initiative was about. Thank you to all of the participants. We do have a couple of other webinars coming up. Watch this space and participate. Thank you. Thank you, everyone.
Thank you very much.
Thank you.
Have a good day. Bye.
Yeah, bye.